Hi, everyone, and welcome to a new episode of the Global AI Notes, where today we're going to talk about how you can create your own Bing chat with Vlad. So let's get started. Hi, Vlad. Welcome to the show.
Hi, Hank. Thanks for having me.
Yes, you're welcome. It's been a long time we've been on a show together.
A
I think
bit,
I
a
think it
bit.
was the last global AI streams, I think still in Corona times. If I've heard from you, right?
Yeah, pretty much. I think it was last year for also for the Global AI event, yeah, in December.
For
I think,
the
but
student conference. Yeah,
time is weird lately. I don't know. It's like we're living in the dark tower now.
exactly. Um, I assume it's also cold and winter on your side.
Very much so. Very not as bad as in other places, but very much so. It's we're preparing for Christmas. It's great for
Yeah, so it's a good
for
time to be
shopping.
inside and talk about AI. So tell me, what are you going to talk to us about today?
I'm gonna show you a bit how to build. So I was really excited when Bing Chat came out. I still am. Use it quite a lot, and I love how it's able to retrieve information from the latest events. I can just ask it, look, who's scheduled to speak on global AI notes, and it might it might return the right answer. So I love that, and I wondered what's the simplest way to do that, with just Azure OpenAI, just the GPT-4 instance.
Mhm.
How can I do it? And yeah, I got what I think is one of the easiest way to do that. And I want to show you how that's done, but also to walk you a bit through, yeah, the reasoning process. Okay, what things we can consider to get info on actual events, what things might work, what things might not work, stuff like that. So just a bit of theory, and then the cherry on top, some working code.
Perfect. Okay, I can't wait to see how you're going to build that. So let's share your screen and get started.
Absolutely. Absolutely. Let me click the right things to click. I hope
Yep,
I did.
I'm
All
seeing
right.
it. And there we go.
All right.
And the
So,
stage is yours.
why, thank you. Well, fingers crossed. Well, so hi. This is poor man's Bing Chat, building a web-connected search assistant from scratch, or pretty much from scratch. Aha. Basically, yeah, what do we want? As mentioned before, want to ask GPT-4 some questions about events that have occurred after September 2021, ideally current events. You know, um, something like this. So basically, just to show a bit of a code, this is my setup for Azure OpenAI. Gonna run some cells in a notebook. So right now, if I'm to ask, GPT-4 what electric models Volvo makes. Sorry for this. Last time I presented this was as an internal presentation for Volvo. This is things I download there. But GPT-4 believes that the latest models from Volvo, it's XC40 Recharge, C40, some plug-in hybrid models, some information that is clearly not quite up to date, right? So I'd like to see the latest models. And question is, how do we get that, right? How do we get recent info in GPT-4 or any GPT, any model? So it might be an interesting problem to solve, right? So let's think step by step. Yeah, not just large language models do that. Also, it also works for humans. So let's think. What are large language models? Yeah, how can we convince them to show recent information? So yeah, as an gross oversimplification of how AI works, I written this function, do AI, that basically it receives an input, and for each, let's say, for each words, but we all know it's tokens, which is a token is basically a word or a part of a word. It's a bit more complicated, but let's just think of words. So in a for loop, the purpose of AI, of GPT, is to just predict the next word given a context. Yeah. So in this case, the initial context is just the input, the thing we're asking. What electric car models does Volvo make? And then it predicts a word. It adds that word to the context. Yeah, it adds it to the input, and then uses that to predict the next word and the next word, and so on and so off. So it's not necessarily about reasoning. It's not about they don't lie, they don't make things up. They just predict the next word given a context, right? And by the way, speaking of that thing step by step gimmick, basically it's one of my favorite things to try when convincing a large language model to to give the best answer it can give, become the best version of itself. There was this really cool research published last year where large language models are zero-shot reasoners, where they showed that if you give a model time to think, and they think in tokens, time to think, by enunciating the problem, reiterating some issues, they get to a much better answer because they predict the next words. So if they have the proper context, and on the right side, the chain of thought, it thinks step by step. It has the right context, so this helps it get to the right answer because they don't really do math, right? They just predict the next words as a parenthesis. But let's get back to what we were trying to do. Now, an idea is, why don't we just retrain it? Yeah, people have done it before. Why don't we just retrain with the latest data? Well, here's a helpful visualization of how large language models are being developed and or trained. I think this is one of the best, to be honest, to help. They help me get my head around it. So you have this huge amorphous blob, where they do unsupervised learning, and that basically, it's like taking all the text on the internet, good, bad, worse, horrible text on the internet, maybe not all the horrible part, but a considerable chunk of horrible stuff, and then they just train a base model on this, right? And basically this model learns to predict the next words, but it's not really good at dialogue. Yeah, it can predict words, it knows grammar, it knows that sentences look like this, phrases look like this, a poem kind of rhymes like this, but not great for dialogue, right? On top of that, we add some supervised fine-tuning where we show it examples of, look, this is what a question look like. If you receive a question, this is what you should answer, right? And we do that over and over and over again. And after we finish that fine-tuning, we also have, some of the models also have, especially OpenAI's, reinforcement learning with human feedback, where we actually get humans picking from various versions of answers. So it's way easier to pick the right answer than to generate the right answer, right? So they pick from various answers generated by a GPT. And I like this best. No, I like this best. This is, go let's go for this. And by feeding this through a reinforcement learning loop, you get a model that learns, not just grammar, not just how to answer questions, but also what kind of answers human like. And incidentally, this is also a reason for why we get so many confident answers. Of course, we as humans, we like confidence, but not necessarily right, because it's hard to sometimes check for that. Right. So just a quick comparison between base models and chat fine-tuned models. For example, if I were to ask, how does Hamlet's famous monologue start? A base model would just decide, this is a list of questions. Okay, I'm going to shoot more questions. So what is the opening line of Romeo's soliloquy? What are the first words of Mark Antony? And what about that Tears in the Rain monologue from Blade Runner? Not exactly helpful, but at the same time interesting, right? Whereas an assisted model, well, that's going to give an answer. In this case, it gave this answer because I prompted it to think step by step. So it's Hamlet's famous monologue, often referred to as the to be or not to be soliloquy, blah, 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 to be or not to be, that is the question. So a bit of a difference. So thinking about this, it doesn't really make sense to do a full retrain. It costs a lot, takes a lot, needs a lot of data. We shouldn't do it just to get recent information. So maybe we can just fine-tune the thing, because fine-tuning is way simpler than retraining everything. And incidentally, this is a bit from the Llama from Meta paper, highlighting their training pipeline. So as you can see, it's really similar to what we discussed before. They have this pre-training step, then is the supervised fine-tuning, where they go from a Llama 2 based model to a Llama 2 chat model. And then it's reinforcement learning with human feedback and all that safety and helpfulness information. And by the way, this is how a fine-tuning dataset looks like. So I'm using OpenORCA as an example. This is based on a very cool Microsoft research paper called Orca. They actually released Orca 2, I believe it was this week. No, last week. We're on Monday. Last week. This is an open data set. And these are some samples of data. So we have a system prompt giving the assistant the context. In this case, you are an AI assistant that helps people find information, blah, 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 blah. A question: John was a terrible writer. To practice, his teacher suggests things. And the response, by the way, it's step-by-step reasoning. The response is step 1, step 2, step 3. And we feed a lot of data, something like 4 million rows of these samples to a model. And yeah, after some hours and or days, depending on how much computing power you have and how big the data set is, you get a fine-tuned model. Now, we have two issues. On the one hand, gathering a data set with all text on the internet is really non-trivial. Plus, it takes a lot of time. Yeah, so if we want to get to current events, that may not be a good approach. And issue 2, after gathering the data set, which took a significant amount of time, then we have also the fine-tuning, which also takes time and computing power, and we need to do that like continuously. We might not want it because it's not as cheap or straightforward. Because basically, once we fine-tune something, it's already obsolete. We want real-time information. This doesn't provide real-time information. So it's back to the drawing board. but here's an idea. So we have that context thing for models, right? Idea would be, what if we include the info in the prompt? just tell it, this is the answer I'm looking for. Okay, what answer am I looking for? And it'll answer, this is what you're looking for. So pam, pam, pam. I could not resist doing that. I'm sorry. So let's talk a bit about context window sizes to really understand what's going on. So remember this this fancy do AI code. What do we mean when we talk about a model's context? Because for quite a while, I believed it was just the size of the input. How many? Well, I'm going to say tokens. How many tokens, which is bits of words, can I send the model before getting a response? But knowing what we know now, that a model just predicts the next word and the next word and so on, that doesn't really make sense, right? So context is not just the input, but also the output. And oftentimes the output is even lower than the maximum context size of a model. See GPT-4 Turbo, right? So in this case, both the input and what the model has generated need to fit in that context. Otherwise, it does not work. No, because it just predicts the next words. So here are some popular models and in their context window sizes. We have the small ones, Llama 2, GPT-3.5 Turbo. They have 4K, so just 4,000 tokens. That's really not a lot. It's good for dialogue. It's fast, but not great if you want to ask it to summarize maybe books or, I don't know, projects, a lot of code. Where it starts getting interesting, it's at maybe GPT-3.5 Turbo 16K, released this summer, where it's 16,000 tokens, and then GPT-4 32K, but not a lot of people have access to that. But what a lot of people have access to is maybe Claude 2. I'm going to just skip on Code Llama because in my experiments, it did not do good or even less than good at all. Yeah, but you have Claude 2, which is has a huge context window at 100,000 tokens. GPT-4 Turbo recently released 128,000 tokens. That's quite impressive. And Claude 2.1, which it's great to be a consumer in when multiple companies are competing against each other. So no to monopolies. So Claude 2.1, where we have 200,000 tokens. So you start getting some interesting stuff. For comparison, I actually tried feeding an entire project, a JavaScript project of something like, I think, 8,000 lines of code, JavaScript, to Claude 2. And using their tokenizer, it was calculated at about 60,000 tokens. So 60,000 tokens of JavaScript, in my case, was 8,000 lines. So in this case, you would get something like maybe 20,000 lines, maybe more. It starts to be interesting for just understanding, project books, whatever. All right, so that's the context size. But of course, while they're impressive and they start evolving really fast, just as a context, GPT 3.5 Turbo with 4,000 tokens was released just last year, a year ago, and now we have 128,000 tokens. So in just a year, it's wonder what will be happening next year. But they're still small. Yeah, you can't fit all the internet in that, and you won't ever be able to fit that because we're producing so much content, and not all of it is human generated, right? So here's another idea. What if we don't send it everything? What do we send them? Well, we include the most relevant info, of course. So we have this pattern that most likely you've heard of it. I know Farzad talked a bit about this some time ago using cognitive services. Basically, it's about retrieval augmented generation, right? And what does this mean? Well, for starters, I asked Bing or BingChat, and then it asked Bing Image Creator. You should totally try them if you haven't. They're really cool. To generate a diagram of what retrieval augmented generation looks like, and it got me this. I don't know what this is. It makes no sense, but I included it just so you know, RAG is way simpler than this makes it look like. Plus, I like the colors. I think they go really well together, right? So here's a sample of how retrieval augmented generation looks like. I figured it's best to explain that using an example. So imagine you prompt a search assistant, you prompt GPT with something like this. You are a search assistant. You help users find information. You were asked this question, and by the way, use only this context to answer the question. Nothing else. Don't make stuff up. Don't do anything. And our job then becomes in finding this relevant info and just passing it to a GPT. And I was reading other companies that have done that, and including Stack Overflow, and they're saying that RAG basically is only as good as the quality of your search results. And you can see that here if you feed it in relevant information. If you feed it crap, you will not get good results, right? So how do we get good results? Well, this is a bit, one way of doing that is using semantic search. So semantic search, as opposed to lexical search, it's not about keywords, not about finding, I don't know, puppy in your database, or pup, or all variants of that word. It's basically about searching using meaning, searching using embeddings. But that's maybe outside the scope of this talk. Just know that this is an important part. You can one way to actually do search really well is using cognitive services. They have some combinations of both semantic and lexical search. So you basically can get the best. I blame the coffee. The best of both worlds. I will not have another sip, even though I'm tempted by the coffee standing right there. All right, but you know what? Semantic search, lexical search, we don't really need that, or we might think we don't. Why is that? Why can we think? Well, this is a screenshot from Boris Power, posted an OpenAI employee, at least last year. Talking about their new embeddings, the new OpenAI embeddings that we can use for semantic search. And basically, they mentioned that it would cost only $50 million to embed the entire internet, and then we can just do semantics, or not lexical, semantic search on the entire internet. And who wants to take on Google? And I realized I do not want to take on Google. They're a big company. So here's another idea. Why bother with all the semantic search and all the lexical search when we can just use Google or Bing? But since BingChat uses Bing, I figured I'd be original and use something else. So we can just use Bing for search. They have a database of. We can just use Google for search. They have a database of all the internet. They keep it continually update. Why not use them? We don't want that kind of problem. So let's see how this works in practice. I have my demo over here. So I'm not going to go through all this code. If you want to take a look, it's on my website. It's I'll just type it here because it's always nice. So it's on vladiliescu.net. It's an older variant of this code, but I'll put an update after this. Just after this. So basically, I'm using the latest version of Azure OpenAI. I'm not using an instance of GPT-4 Turbo, even though I really wanted it. It has some, let's say, performance issues from what I've seen. So it wasn't always, it would time out often. So I'm back to good old GPT-4, confined to only 8,000 tokens and a knowledge cutoff of September 2021. Just so you know, I tried using something more modern, right? So how do we do that? Well, on the one hand, we have my query. Tell me what electric models Volvo makes. And first things first, that's good for semantic searches, but it's not good for lexical searches like Google or Bing. Yeah, so a first thing would be to just prompt GPT-4 to convert these instructions to something that can be used for Google, for getting great, even best results from Google. And notice, here's me just trying to get it not to add any type of single or double quotes, just the raw query. You can imagine how I got there. Right, so we're now having this optimized query, which is great. It mentions Volvo at the beginning. It's optimized for search. It has the most important words at the beginning, and then decreases. It's really cool. And then, this code was not written by an AI. It was copied off Stack Overflow. Human intelligence for the win. It works. I also adapted this. So I did some work here. I not want to brag, but it's also part of me in there, right? But basically, we can use this to get Google results for an optimized query, and then we have some interesting results. So I'm not gonna show you all of them. I'm not gonna take into account all of them. I'm just gonna get the first one, right? So we're gonna get the best results. This is the page I'm using. I'm just returning the first one, and let me start with the conclusion, and then I'll get back to how I did it. So basically, you see, we have an unprocessed page. I'm also doing some light processing, and then converting the whole thing to Markdown. Why? Because the unprocessed page is really big. So it has a lot of HTML content. I don't want that. So it has something like 350 kilobytes, right? And almost 120,000 tokens. So if I were able to use GPT-4 Turbo reliably on Azure, I might have used this, but otherwise it would have cost me quite a bit, because that's a lot of tokens. But it would be more efficient to just process the page. So it's only 3,000 tokens. So really big difference. And how did I do it? Well, I'm using this HTML to text library, whose whole purpose in life is to just convert HTML to Markdown. Then I'm telling it, okay, I don't care about links. I don't care about images. Don't care about mail to links. Maybe keep the tables, because this way I get this structure. I could have just taken the text from the page, but then I wouldn't have had this rich structure that Markdown supports. I wouldn't have had headings. I wouldn't have known, that these are subheadings, but maybe with two sharp signs, time to recharge, home or away. And it knows that these are the subheadings of this heading and so on. It has structure. I love Markdown for this. So now we have this content. We're going to feed it to a GPT. How does this look like? Well, I'm just, here's a very quick system prompt, the kind I've shown you before. You are a search assistant. You help users find information. You have this query, several title, URL contents. You'll notice this prompt is optimized for maybe multiple documents, because I'm telling it to answer in this format and also include a reference to the document URL. So you can send it multiple documents. I wanted to do that at the beginning, but then I just figured I'd overcomplicate this and it would not be the simplest way to do it. Hence, I didn't, right? So this is the system prompt. This is priming the model, giving it some context about what to expect and what to answer. And then the user prompt is just this query, the title of the document, the URL, the page content. I'm just, then I'm calculating, I'm doing a bit of a trick here. In case the page is larger than 8,000 tokens, just trim it to 8,000 so it has some space to also answer, right? So I'm getting the tokens. The tokens are an array of numbers, encoding it, and then just use the first 8,000, right? And then these are the chat message helper functions, and this is my code. This is the chatbot. So you'll see, I'm asking, tell me what electric model Volvo makes. I get an answer, and then I'm asked for another question. So let's say, I don't know, list the characteristics of BX30 and BX90. While it answers, let's go through what this does. So you'll see I'm defining this conversation. So at every step, I'm sending all the messages, all the history of the messages to the model. So I'm defining the conversation with a system prompt, the first user prompt trimmed. We set it here. And then in a loop, we just get the response and the token usage, because I'm also displaying how many tokens we use. printing, we print this message over here, and then just appending the response of the assistant to the conversation array. Remember, at every time we send all the conversation to the model, ask for the input like you see here. Well, let's say, I don't know what it answers, but let's say render them as a markdown table, please. Right? Appending the user input to the conversation with different roles. You see, there are different roles, and the first prompt was a system prompt. And if I don't answer anything, just break. So let's go through the conversation. It makes this electric models. Got this reference. Okay, these are the characteristics, and it can do tables. So and you'll notice at every step the total number of tokens is increasing. So thinking from a pricing perspective, at each step you pay for the entire conversation you've had, even though you've had it, because these models are stateless, which is a good thing to remember. Yeah, and there are various techniques to optimize this. Maybe take a look at semantic kernel or LangChain. You can really just summarize the entire conversation that took part so far, or just cut off, keep the latest number of tokens. But this is the general idea, and this is, my friends, the simplest way I found to create a chatbot that's connected to the internet. Now, I had some interesting things to show about functions, but it's best that you just take a look at them yourself. Just want to show you the result. I have not run this code, but basically, they don't know anything about time or stuff like that, but you can give them tools, and not a lot of code. So now we know there are 27 minutes until lunch, in Romania at least. All right, so that's what I wanted to show you. If you want to know more, or just take a look at the code, it's on my website, so vladiliescu.net, or my Substack, which I named squatted long ago, vlad.substack.com. Thanks so much. And usually I'd ask if there are any questions, but Hank, do you have any questions?
Let me switch back. Oh yeah, here we are. Okay, that was super interesting, Vlad. And I think you had like a lot of cool call outs to things you should know, like that you all the time have to send all the context, that these models are stateless. They don't remember anything. I think that's one thing I heard
That's
a lot.
fun.
Like, how does it work? Why do I have to do that?
Yeah.
So that was a very, very, very good call out. The slides are available, and your code for people to take a look at.
Absolutely.
On your
I can
Substack,
share it
right?
on where should I share them?
Yes, in the chat maybe.
Yeah, all right.
And let me see if we have any questions. Nope. So far we don't have any questions. So what I will do is I will copy and paste this link and share it here in the stream. So it is always there. And there it is. Cool. Yeah, thank you so much for joining us today. Are you going to watch the Global AI conference that's going to be on the 12th of December?
Of course, looking forward to it.
Yeah, we will have like almost 12 hours of 30-minute sessions with covering, I think, a lot of topics. Cool. Then I wish you a nice time until lunch. What was it? Like an hour? Still 1 hour?
No, it's 25 minutes.
25 minutes. I
Yeah.
still have to wait 1 hour and 25 minutes from here. Yep.
That's what I use AI for.
Perfect. Cool. Thanks, everyone, and I hope to see you all back next week. Bye.
Thank you, Hank. Thanks, everyone. Bye.